Hi Algebra 2, this is Unit 8, Lesson 3, and today we're going to talk about the basic exponent properties. Now we already talked about these in the beginning of the year in a little bit, and you also did them back in algebra, so this should be nice and quick and easy to do. So the product rule, product means multiply. When I'm multiplying two exponents together, when the bases are the same, you keep the base and you add the exponents. So x to the a times x to the b equals x to the a plus b. So you keep the base, add the exponents. This only works if your bases are the same. So looking at exercise 1, we just want to write these in simplest form. As long as the bases are the same, the bases are your x's, you keep the x, add the exponents. 3 plus 8 is 11. For b, 3 is your base. So I'm not multiplying 3 times 3 is 9. 3 is the base, so I'm keeping the base of 3 and I'm adding the exponents. 3 plus 5 is 8. And C, I have some numbers in front. So 2 times 4 is 8. And then I look at the x's. So x squared and x to the third. So I keep the base of x and I add those exponents. 2 plus 3 is 5. And then if I don't have a number, like on this y, this is really y to the first power. So 1 plus 5 is y to the sixth power. Okay, so that's the product rule. Quotient rule. Quotient means you're dividing. So when the bases are the same, you keep the base and you subtract the exponents. So x to the a over x to the b equals x to the a minus b. What does that look like with problems? So on A, 6 and 12, I'm just going to reduce that fraction. So that's going to be 1/2. And I have x to the 10th divided by x to the 4th. So I keep the base and I subtract those exponents. B, I have x to the 6th over x. So that's going to be x to the 5th. I subtract 1. And I have y to the 3rd and y squared. So I subtract 3 minus 2 is y. If you wanted to write y to the 1, you can, but it's certainly not necessary. And C, 5 is my base. So this is 5 to the 8, and this is 5 to the 1. So I keep the base of 5, and I subtract those exponents. All right, 0, the exponent rule. Any base raised to the power of 0 is equal to 1. Anything to the 0 power. So x to the 0 power is 1. F to the 0 power is 1. 9 to the 0 power is 1. This whole thing to the 0 power is 1. All right, so that was quick and easy. Next page, power rule. We write the base and we multiply the exponents. So when you have a power to a power, all right, so like here, x to the a and that whole thing is to the b, that equals x to the a times b. Power to a power, you're multiplying those exponents. The way you're going to remember that is that I have parentheses, like look at A. See how there's a parenthesis between the 5 and the 2. So that's going to remind you, hey, I have to multiply those numbers. So that's just x to the 10th. On B, 5 is your base, so I'm multiplying 4 times 9. On C, a little multiple choice, which of the following expressions is not equivalent to x to the 30th? So 10 times 3 is 30, so that one's equivalent. 6 times 5 is 30, that one's equivalent. When I'm multiplying, I add the exponent, so this is actually x to the 11th, so there it is. That's the one that's not x to the 30th. 4 is okay, because again, when I'm multiplying, I add exponents, and that would be x to the 30th, so that one's okay also. Expanded power rule. Each factor of the product is raised to the new exponent. So that whole thing is raised to, see how I have parentheses and then I have the a? Everything is to the a power. So x is to the a power and y is to the a power. And same thing applies with this fraction right here. So I'm going to have x to the m power over y to the m power. Right? So that exponent goes to everything inside the parentheses. So on A, when I have a number, the 2 is to the 3rd power, so that's really 2 times 2 times 2, which is 8, and then the x is to the 3rd power. Now the x is just x to the 1st power, so 1 times 3 is 3. So everything inside the parentheses is to that power. So on B, 7 is to the 2nd power. Well, 7 squared is 49, and now x to the 5th to the second power, I multiply those exponents. And on C, 2 is being squared, so that's 4, and then I multiply those exponents, x to the 4th, that stays on top. And then on the bottom, the 3 is being squared, that's 9, and I'm multiplying the y to the 3rd to the times 2, and that's going to be y to the 6th. Negative exponent rule. So basically the way that I make a negative exponent positive is that I just put it in the denominator of the fraction. So this is 1 over x to the positive a. So when you're doing this, all final answers must have a positive exponent only. If a factor in the numerator or the denominator is moved across the fraction line, the sign of the exponent is changed. So to make a negative exponent positive, you move it to the other side of that fraction. So numerators will move to the denominators, denominators will move to the numerators. All right, so I have 1 over x to the negative a. I'm going to move it up top, and it will become x to the positive a. And then this was a little hard to type out, but this whole thing, x over y, is to the negative a power. All right, so the way I make that positive is that it's x to the negative a over y to the negative a. So each of them have to flip-flop. The y's are going to have to come to the top, and the x's are going to have to come to the bottom. All right, so a, I need to make that positive. It's 1 over x to the 5th. I move it to the denominator. B, I have to make that positive. I move it to the denominator, 1 over 5 to the 3rd. C, I need to make that positive. I move everything to the denominator, okay? But now the whole thing is still being squared. So negative 3 squared is 9, and then I'll multiply those exponents. The 6 for the x times 2 is x to the 12th, and y is just 1 times 2, so that will stay 2. D, I'm going to multiply those numbers, so negative 3 times negative 4 is 12, and I'm going to multiply x to the negative 3 times x to the 1, because that's a 1 right here, is x to the, oh, when I'm multiplying, sorry, I'm not multiplying the exponents, I'm adding the exponents. So that's 12x, now I add the exponents, so it's x to the negative 2. And again, I'm going to add the exponents. I have 6y's and y to the negative 5th, so that's y to the 1. Now the only thing that's negative is that x. So the x is the only thing that needs to move to the denominator. The 12 staying on top, the y staying on top, and the x squared will move to the denominator, so it's positive x squared. So these can get a little bit tricky. And E, I want to know which expression is equivalent. So basically, I'm going to leave anything on top that is positive, although there isn't anything. Everything's negative. But the 2 is going to stay on top, and the 4 is going to stay on the bottom, but I'm going to have to move those exponents. So I can reduce the 2 over 4, because that just reduces to 1/2. All right? The y to the negative 5th on the bottom is going to come up to the top. The x to the negative 2 on top is going to move to the bottom and become positive 2. And the y to the negative 2 on top is going to move to the bottom and become y to the positive 2. So this is just 1/2. And the y to the 5th, I'm dividing now, so I subtract the exponents. So that's going to be y to the 3rd, and the x will just stay on the bottom. Right? The y's had a common base. I was dividing, so I subtract my exponents, and I can see that answer in choice 1 there. All right, so those are the rules with some examples. Let's just do a few more problems to practice. So remember, an exponent applies to only the factor it is next to unless parentheses enclose other factors. So this is something that I really wanted to stress. These are 2 different problems with 2 very different answers. On A, the whole thing is going to the second power. On B, just the 4 is to the second power. All right, so this really means negative 4 times negative 4, which is positive 16. This, the negative's hanging out in front, and it's really just 4 times 4. So, which is 16, but then the negative is still there. So this answer is negative 16. So the parentheses totally changes the answer, so you need to be careful with that. All right, so do this quick practice with me. Number 1, I'm multiplying. Think about, what do I do when I'm multiplying? Add those exponents. 2, again, I'm multiplying. Add those exponents. 4 plus negative 4 is 0, but anything to the 0 power is 1. 3, I'm multiplying. I multiply the numbers in front. 7 times 5 is 35. And now add the exponents with the common bases. So x to the 3rd and x to the 1 is x to the 4th. And y to the 2nd and y to the 9th is y to the 11th. 4, I'm multiplying. They all have the same base. Keep the base and add those exponents. 10 plus 2 is 12, and 12 plus negative 4 is 8. 5, I have a power to a power. Remember, those parentheses are going to remind you that you're multiplying those exponents. So it's x to the 15th. 6, everything is to the 4th power, including that 3. So 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. And now the x squared, a power to a power you're multiplying, is x to the 6th. On 7, again, everything is to the 6th power. So 2 to the 6th power is 2 times 2 times 2 times 2 times 2, which is 64. And that everything is to the 6th power. Power to a power, I'm multiplying. 3 times 6 is 18, so I got x to the 18th. And that's a y to the 1st, so 1 times 6 is 6. So be careful with those parentheses. 8, I have division. Now remember, on division, what are you going to do with those exponents? You're going to subtract them. So this is x to the 5 minus negative 2, which is x to the 7th. You don't need that in-between step. I was just showing you. On number 9, again, I'm going to subtract. So c to the 4 minus 8 is c to the negative 4, but I can't leave a negative exponent. So it's 1 over c to the positive 4. Think of it like this. You have 4 c's on top, and you have 8 c's on the bottom. And the 4 c's on top are canceling with 4 of the c's on the bottom, but I'm still left with 4 c's on the bottom, and I'm left with just 1 as a placeholder on top. All right, if that helps you to visualize it a little bit better. All right, number 10. Everything is to the 3rd power. So this is 6 to the 3rd power and z to, that's a z, z to the 4th to the 3rd power. Well, 6 to the 3rd power is 6 times 6 times 6. That's 216. And a power to a power, I am multiplying that. All right, 11, I am going to, you can actually cancel on 11. See how I have x to the 3rd on top and x to the 3rd on top? All right, so that's leaving, and then I have one of these y's can cancel with one of the y's up there, but you're left with 5 on top, 2 on the bottom. And now I have 3 y's on top and 1 y on the bottom. When you're dividing, you subtract those exponents. So it's 5z, it's not z, 5y squared over 2. And the very last one, anything to the 0 power is 1. Just the 9x is to the 0 power, so that's 1. And that negative is hanging out in front, so that negative stays there. Okay, and that's it for lesson 3. We will practice that tomorrow.